All right, hey guys, welcome to this panel. We have a couple people here. I'm excited to chat about interoperability and cross-chain infrastructure. So I'll go ahead and shut up and let everyone give a quick intro about themselves, just like who you are, what you do, everything like that.
I'm Solomon. I lead infrastructure engineering at the Solana Foundation, as well as lead product. Work with a lot of validators, RPC providers, data providers, bridges, and the whole thing.
I'm Kian. I'm part of the Polkadot Core Fellowship, and I have a history working on the proof of stake system of Polkadot. Happy to be here.
Hello, I'm Yen. So like everybody else, I do everything in the blockchain space. I write circuit before, and I write smart contracts as well, and anything. But I identify myself as a formal methods expert. I did smart contract auditing before, and now we're bringing formal methods to application, actually. So we'll discuss that later. Very happy to be here. Thank you.
Amazing. Thanks, Jan. Hey, I'm Ozzy. For those that weren't here before, I'm integrations lead at Wormhole Foundation. I work on all sorts of things like new verification mechanisms, new product lines, everything. Intents, data, you name it.
Cool. I think a good place to start is for the infrastructure providers in the projects. Maybe give a little bit of background about what exactly solution or what solution you're building for, what kind of unique problems are you solving? And Ozzy, if you want to kick it off.
Yeah, 100%. Yeah. So I want to say the beautiful and also at the same time the kind of ugly thing about Wormhole is that it's basically 8 or 9 products rolled into one distribution network. So how do you make sense of all of that? Well, we have all sorts of layers. At the bottom, you've got your general arbitrary message passing. At the moment, that's controlled by a lock-in set of verifiers, Wormhole Guardian Network. On top, you have token framework, entity token framework. We're moving towards a modular future. So how does that look? We have intents, we have liquidity layers, composable intents, we have data products, we have relayers. So we have front ends as well. So you have a full vertical integration of interop, basically, and a massive distribution platform. And as we open up, there are massive opportunities to really harmonize, I think, across the entire ecosystem in terms of distribution, verification. How do we do all those things? We have to do them together.
I know Yen, you at Pi Squared, you guys have a slightly different approach, so it would be good for you guys to talk a little bit more about that as well.
Yeah. So we are more like building the foundational technology in this space that, as I said, bring formal methods into it. The purpose is that the first thing we want to minimize the trust setups, especially in cross-chain applications. But that thing you might heard everywhere that based on ZK proof and claims, etc. But the thing that I want to emphasize is actually the second point, that we actually bring universality into this space. Universality that we will allow programmers in any programming languages to be in this space and to do cross-chain applications as well. So that will be very interesting. I'll talk about that later in the second question, I guess. But that will be very interesting. So we set up the minimal trust base, and we bring any language and any developers, any smart contracts into any chains. That's basically it. Thank you.
Kian?
So if I want to describe first of all, before I think having more trustless bridges and verifiability and cross-chain communication is super important. So I'm glad you brought that up already. If I want to demonstrate how Polkadot plays a role as an infrastructure, originally, if you look back at what Polkadot intended to be done, is a multi-chain environment, and Polkadot throughout the years of 2020, 2021, and 2, build a specific product to do that. But over the course of the last 1 or 2 years, and still ongoing, we're actually moving toward decomposing the elements that we built to have this multi-chain environment, such as sharded execution, data availability, and provide them as a standalone product as well. And this is something that's ongoing. There are projects now that in Polkadot that are acting as a co-processor for other ecosystems. So we're trying to, through the technology that we originally built for our parachains, but we kind of realized, okay, this stuff is kind of cool. We can use it for more things. We're trying to actually act as an infrastructure on many levels for other ecosystems.
And Solomon, I think it would be good to get your perspective on at Solana. what are the kind of unique challenges that Solana faces with respect to interoperability and cross-chain?
Yeah, so to give some initial context, right, the Solana Foundation is a Zurich-based nonprofit, 501c. We do not build our own products, but we do coordinate across a multitude of different entities, which are just infrastructure providers and application builders within the Solana space. So the way that we usually interact with these teams is if they're migrating to Solana or they're adding net new Solana capabilities, they want to say, okay, I'm EVM based. The SVM is a completely different beast, right? Like, how do I actually integrate with that? And in most cases, people might not actually rewrite their contracts in Anchor or rewrite their contracts into native Solana. They might just bridge their token, or they might just bridge some NFTs and then have some interoperability between both of the chains. And so from our POV, at least on the infrastructure side, we're really just introducing these teams to write every different bridge based off of whatever their needs are. So one use case that I've seen previously is some consumer social teams want omni-chain USDC balances. They basically want like an intent solver system where I have $10 in USDC on Base, I have $10 in USDC on Solana, and I want to buy this NFT on Solana. How can I aggregate both of those balances and then actually put in that order to buy that thing? And so we're trying to work with a bunch of different teams to make sure that we have the right, if you're using smart contract wallets, right, you have like the passkey curves. If you don't want to use all of the balance on Solana and you want to keep it on Base, like you can do that. If you want all of your tokens on Solana and you don't want to just like have omni-chain balances, how can you migrate your entire system over into a Solana first approach? So we're really just a coordinating entity between all of the different providers and then trying to find the right solutions for them.
Gotcha. This is a question for both Kian and Solomon again. What do you guys view as the role of Solana Foundation or developers on Polkadot or Polkadot itself in kind of facilitating cross-chain infrastructure, working on interoperability? There's projects and then there's the foundations. Kind of what do you guys view as the role for each?
Yeah, I mean, there's a lot of pieces here. I think one thing too is that Solana also is getting a lot of steam on the L2 front. There are a lot of people building like SVM-based L2s, both settling to Solana and then settling to Ethereum. And for us, at least, the foundation is very focused on this meme that you've seen online, which is like IBRL, which is increased bandwidth, reduced latency. And so a lot of the foundation focus is actually on scaling the main chain. And so when we have these new application builders or these new infra providers that want to build L2s or side chains, we're definitely focused on Solana first, but we are not opposed to helping a lot of these other teams actually build. And so one thing that is like missing in the Solana ecosystem is like a chain ID. If I have multiple SVM providers and I want to bridge between a lot of them, how do I actually know which chain I'm interacting with? That's something that the Solana Foundation can help build, a working group around, standards around, and it's something that I've talked to Coinbase about a lot too, because they're building this, I forgot the RIP that they're building, but it's like a cross-chain intent protocol. And they're basically like, yeah, it works on all EVM ecosystem, works on every other chain we're building on, but Solana is a completely different beast, and it doesn't have a chain ID, and it doesn't have all these other things that are required for me to actually interact with multiple chains. And so from our perspective, we're helping on standards, on working groups, and then sort of getting everybody in one room or like in one Zoom or one Discord call or one Telegram or whatever, then making sure that everybody's aligned, and then we have something going forward.
May I ask you to rephrase the question one more time?
Yeah. So on this panel, we have people from foundations and the blockchain networks themselves, and then also infrastructure projects. What do you think the role is for each of them in promoting this infrastructure and interoperability?
So I'm going to speak as Polkadot as an ecosystem, more or less. I'm not here as part of a particular group or foundation per se. But I think the role that Polkadot is trying to play in the broader blockchain ecosystem in this regard is to demonstrate ways through which we can have interoperability and scaling without sacrificing a lot of the security that you would get in a traditional blockchain that just doesn't talk to anyone else. Yeah, I would name it as such. In that, of course, for the projects that we have in our own ecosystem, so the Polkadot native parachains, Polkadot provides like a layer of shared security to all of them, so when they interact with one another, they have guarantees about the finality of the other chain. It's kind of like they're bridged in an ideal way out of the box, so as if they have like full light clients of one another and they can verify all the messages. it's kind of like similar to my first answer. I think we have experimented and built a lot of technology for Polkadot native use cases. And now we're trying to see how we can export that to the broader ecosystem and showcase it. So our goal is to have our goal is to have is to see a blockchain industry as a whole where most of the scaling is happening in a way that security and resilience is not compromised. And similarly, interoperability is implemented in a way that security is not compromised. So,
Gotcha. Now, more of a question for Ozzy and Yan. We've seen a lot of progress in cross-chain infrastructure the past 12 to 24 months. I'm curious what you guys view as currently the biggest missing pieces, and what is Wormhole or Pi Squared? What are y'all doing to kind of solve those problems?
Yeah, actually, this is interesting because I think, me and Yan are very complementary in this way, and we're actually working together to help solve these things in a lot of ways. So, Yan and the team is bringing, not to answer for you, these guys are bringing rigorous formal verification and mathematical vigor to giving these security guarantees. And they're making this, the universality of it means that you can write in any language, you can bring basically anything, generate a mathematical proof of anything from, basically anything you want, generate a small snark, and then you can just verify that wherever you want. So that's fantastic. That's almost like the way these guys frame it is almost like a holy grail in terms of, the universality of it all. We bring the other side of that. We're sort of the yang to the yin in this sense, where we have the distribution network already. We're fully vertically integrated with some of the largest protocols across the entire blockchain ecosystem, from front ends to data, propagating governance messages. That happens through Wormhole Guardian set right now. It's tried, it's true, that's fantastic, and it's already integrated. So we can bring in these new verification mechanisms and be able to use the Guardian network alongside of those as a sort of like on-ramp, use the distribution platform that we have, continue to add products and features as we're going now, like adding in an intense layer, composable liquidity, intense plus arbitrary type messages, continuing to expand our reach with adding more VMs in, understanding that developers, users, protocols, new chain builders, maybe not the new chain, but everyone else will want to be able to tap the unique properties of each chain. As Kian's, as the guys have both pointed out, each chain has like its own unique properties. Developers want to be able to seamlessly tap those. You want to provide a great connectivity tissue. And in between those, you want to provide the right verification mechanisms. So you want to bring everyone on this journey, and you need to open up to allow that to happen. That's what I really think.
So thank you, OC First, to giving the support in the cooperation that we actually backed each other and complementary, that we actually provide this product called the Universal Settlement Layer to actually back up the wormhole bridge with additional attestation that you can actually, anybody can verify. So that's actually a typical use case that we were claiming that we minimize this kind of trust setup between the cross-chain communication. So think about this. What's the difficulty of cross-chain communication, and what's the difficulty of interoperability? The thing is, what happened on the other chain, you can't verify it. And the current solution is that you kind of have to trust a third party, right? Either Guardian Network or other kind of bridge or anything like that. So, but the third party is a kind of a large attack surface that anything can happen to that third-party bridge. But the thing is that people might think, in the destination chain, can I actually, using my consensus network, using my own trust infrastructure to perform this kind of validation, can I do it? Then there are two problems. The first thing is, how are you going to verify what happened on the other destination chain? And the second thing is, how I cross the language barrier. So let's see the validation, a validation of a state. What kind of mechanism we have right now? So in the typical blockchain space, you have consensus. And what consensus does, they do re-execution, right? So if on Solidity, if in the Ethereum you have a solidity contract, when the leader proposed that after the block of transactions, you have these kind of ledger state being updated. And what they do reaching consensus is that each node will execute this contract to see if they reach the same ledger state. And if yes, they vote. If they no, then there is a no. Can you do that in Polkadot ecosystem? Verify a solidity contract?
Actually, is that a question?
Yes
Should I
or no?
take one first? I really resonate with everything you said. And actually yes. And let's first elaborate a bit more on that. I think it's very useful for our audience to get the problem statement. Tell me if you agree with what I'm saying. End of the day, it's impossible to have a fully trustless bridge unless if you do either of the two things. Run a light client of the other side on your own chain, or a full client if you're brave enough to try that, but everyone tries light client. And this is like super, super important, because if not, you have no way to know if you can trust the other chain to have actually done something. And yeah, when it comes to, for example, Polkadot, we have, again, within the Polkadot ecosystem, this is something that through the functionality that the relay chain provides to parachains, it's like out of the box. But we have also been conscious in like bridges that we have built, for example, to Ethereum. We actually do run a light client Ethereum right now on Polkadot. So if you look at how Snowbridge is working, it's, I'm not sure if this claim is correct to say it's the only one, but it's probably one of the only light client-based bridges to Ethereum that's actually interacting with Ethereum, bringing liquidity back and forth. And it's working on the basis of Polkadot running an Ethereum light client as a part of its state transition function. And there's an Ethereum Solidity contract running on Ethereum right now, running a Polkadot's grandpa finality gadget, like a Polkadot's finality. And through this mechanism, we can at least be sure, like Polkadot can be sure that this particular block header and state root was valid in Ethereum, and then we can take it from there and make it trustless. So
I was expecting yes and no answer, but it's
actually,
more than information I get.
Yeah.
But come back to the question when you say that actually either you run a full node or you run a light node. So let's look at the full node solution. If you run the full node, which means you have to EVM installed in your node, right? And then if you wanted to, let's expand a little bit, not really to you, but address to the audience, that if you wanted to execute or verify another contract language, for example, Ink, or I don't know, maybe Rust contract or something, anything, maybe a customized contract as well, then you have to install each of the VM on your node. Is that terrible? How are you going to schedule it? How are you going to operate a node like that? But we can do it. The thing is that we provide formal semantics for each of the language, which means we have an intermediate language, which we call it K. Each program language, we have a formal definition in K of the execution semantics of your language. And after you have these semantics ready, you only have to install one machine, which is the universal language machine running on K, to execute language, a smart contract in any language. So that's one of the solutions we provide. So you install ULM, you run any contract you want. Okay? So then let's, I'll be short. So let's look at the second solution, which is the light client. Light client is also a very promising solution. We've been looking into it as well. Then the light client, so light client is that actually you have like a summarization or kind of abstraction of the source chain state on this light client, and you can do very quick verification by querying it. The thing is that the light client will store the a kind of abstraction or like a proof of the source chain information, and then you will have to also, if you are attesting like solidity, and then you also have attesting the Ethereum chain, you have Ethereum ledger states or like block hash stored, and also the Merkle proof stored. Then for other chains as well, which means the light client will be get heavier, or otherwise you have to query multiple ZK light clients. That's another solution we're actually providing, that we have universal settlement layer. So based on the universal language, and also that we have this kind of claim concept, you can think about it, the claim concept as mathematical proof or Zk proof if you want. We bring the succinctness into this place. So use only on this universal settlement layer, which is short for USL. In this USL, you can actually bring all the claims, where the claims is actually it includes lots of information of the transaction hash, the block hash, and also lots of the storage Merkle proofs as well. So you include all the things in a claim using the mathematical proof or Zk proof in this claim. And you store all the block header of each of the chain on universal settlement, where universal settlement will have like a single truth space. And every other chain can just talk to this to fetch the proof, fetch the block header with an inclusion with a Merkle proof, and then you can do the verification on your own chain. So that's why we provide two kind of a solution, the USL and the ULM, to bring universality and also like seamless and trustless approach into this space. Sorry, take a bit long time.
Yeah, no worries. For this next part, wanted to shift things up a little bit. Maybe everyone can go down the line and share a hot take that you have within interoperability and bridges or something outside. And yeah, maybe starting with Solomon, and everyone should feel free to chime in.
Man, I have to start. So I think one thing, so to expand on a comment that I made earlier, which is Solana is focused on IBRL, which is increased bandwidth, reduced latency. That really means that like the cross-chain focus for us is on entrenched liquidity and liquidity coming from other ecosystems and liquidity not escaping our ecosystem and going to others. So cross-chain compatibility really matters for me when a base transfers over to Solana, or when somebody on Optimism transfers over to Solana, when a sidechain migrates all of the liquidity, all of their users over to Solana. My perspective is like I don't really care if liquidity is leaving. If you see a majority of the DeFi Llama stats, a large majority of liquidity is actually leaving these other ecosystems and coming into Solana, and that is kind of our core focus.
Kian, any hot takes from your side?
I think we talked a lot about bridges, and I got a message through about that. I think I want to say something about multi-chain as a whole. So I would put it this way. I think having a multi-chain environment is analogous to horizontal scaling, as in you acknowledge that, the base system that I have is not scalable enough. Let's scale it, horizontally into multiple entities. And then we have vertical scaling, what I think Solana is doing, and is the frontier on it, which to like vertically scale. Let's make it as fast as possible. And we, again, like Polkadot being one of the early players in the multi-chain narrative. I think we were the first sharded blockchain in some ways. We have learned that the fragmentation that comes with a multi-chain environment is also something that is should not be taken lightly, and it can be very difficult to deal with. And this fragmentation is at many levels. Like these shards, these chains have to now communicate. Liquidity get fragmented. Ecosystems also get fragmented. Like tokens get fragmented. Communities get fragmented. And if one day, the base layer becomes suddenly scalable enough, I think then you're like, okay, why did you do this? Or why did we do all this from? And seeing Ethereum going so quickly toward everything becoming a separate L2, I do wonder if in a few years Ethereum becomes 10x faster, what's going to happen to all these L2s? That's fine.
Yeah, and anything from you?
Yeah, so my hot take will be 3 words: correct by construction. So it's a domain terminology, informal methods, and mathematics. As I said in the last answer, that everything comes down into this formal semantics of your language, because you have to generate proof and the proof from it. So the correction, I will try to use 1 or 2 minutes to explain this. This is essentially the how formal methods actually works. So let's think about arithmetic operation. You have the integer domain. You have your plus and minus arithmetic operation. How formal methods tackles with it? So first, we use 2 rows to represent the integer domain. The first one is a base case, which is 0. The second row is actually a successor row. So if you're given an s as an integer, the successor will be s plus 1. Okay? Use these 2 rows. That's good enough to represent the whole infinite integer domain. And then you can derive more rows based on these 2 rows. What we say derive is that we can prove additional rules using these two rules. So, for example, if you like typical, maybe you have learned in your mathematical class that we have commutative rules, we have distributive rules, and we also have associative rules and also identity rules. That's essentially the 4 rules that is in the addition operation domain. And then these 4 rules can both be proved by the 2 basic rules. And then that 6 rules in together makes the whole logical system that you can represent the arithmetic operation. Okay? So that's how 4 methods express the computation problem. And then what we do calculation, if you want to calculate like 3 plus 4, if we consider this as simple calculator program, and when you execute this program, you actually execute it step by step. And each step, you have to quote and reference one of the 6 rules. Okay, so each of the step has to be backed by one of the proved rules. Then at the end of computing 3 plus 4, you get 7. You have the execution steps recorded as using the execution semantics. And also you have a list of rules to prove why each of the steps is correct. So the computation, which we say in 4 methods, execution of this semantics is backed up by the rules you have that is proved. That's how we say correct by construction. And given a bigger problem as a program, like Solidity program or Rust program, that's how we code this problem. So each time you execute the contract, you will have evidence of proof of your execution. And that's something everybody can verify, not just K-verify. You can maybe use a link or other provers to verify it. But in terms of to increase this kind of scalability or like in the Web3 space, that we did a further step that we fuse mathematical proof with ZK proof, that we build this kind of ZK proof on top of the rewrite circuits and build ZK proof on top of the mathematical proof. That is how we actually eventually bring ZK technology to any languages. And the rest, you can just imagine it. I don't have to explain. Thank you.
And Ozzy, what about from you? Your spiciest take?
Spicy take. I think that the increased complexity that we're seeing, explosion in like roll-ups, verification mechanisms, all of this will actually will drive much more streamlined applications for the entire blockchain ecosystem. Absolutely. It's going to make it so much better, the increased complexity. And why? Well, it's because these protocols will be able to tap different blockchains for their different needs. Right now, actually, let me use an example. 70% of the cross-chain message bridging that we see is for value transfer. So we've got our native token transfers framework launched in April this year, securing $55.5 billion in value on chain. Most of the wormhole messages are token value transfer messages, but I think that there's going to be an increased scrutiny and importance on the arbitrary general message passing, which is so important today. It's what enables, DeFi protocols to propagate governance upgrades across multiple chains, SVMs, Solana V2s. Like it's gonna keep getting more complex, and that's going to drive unification. It's going to be fantastic.
Awesome. I think that wraps up our panel. Appreciate you guys taking the time to share all your insights.
Thank you for having us.
Thanks.
Thank you.
See you later.